Hey everybody, thanks for coming to the talk today. A lot of good talks, especially in this time slot, so appreciate you carving out time and coming to this one. Now, I assume if you're showing up to this talk that you use pandas and interact with SQL databases a lot. And if you do that, you've probably noticed that it can be kind of slow and it has some rough edges. So we're going to talk about that today, and I'm going to introduce these new ADBC drivers that work with Apache Arrow and make that much better, much faster, much more fun. So let's just talk today, though, about the current state of pandas interactivity with SQL databases. If you're new to pandas, you look at the documentation, the first thing you see is to-SQL and from-SQL. And these typically work in coordination with a driver, ODBC usually, or JDBC. SQL Alchemy is somewhere in there. You can not use either of them if you use SQLite 3. Not a lot of people do that, but it's there. And like I said, this is kind of great when you first start out. You'll find quickly that there are limitations with time, complexity, and data type management today. So what a lot of people do if to-SQL and from-SQL aren't enough today is they end up moving files around. Historically, you see people drop CSV files somewhere and the database would pick them up. We're, I think, as a society, moving away from CSV into more Parquet, which is good, but still not every database can support a copy of Parquet. So you start getting into database-specific features, but if you have copy as a database, you've probably seen in the past that copying files is much faster than using to-SQL and from-SQL. And in some cases, you may rely on specialized libraries. So I've done a decent amount of Redshift work in my day job, and specifically with Redshift, they have this library called AWS SDK for Pandas. It used to be called AWS Wrangler, and they would implement their own kind of custom way of taking Pandas data frame data and pushing it high performance into a Redshift database. Okay, so this is all great, but it would be even better if to-SQL and from-SQL just worked better and were faster. We didn't have to worry about files. We didn't have to worry about specialized libraries. And again, even though we're not quite there today, we have development going on in the ADBC space that I think will make that a possibility sooner than later. So I wanted to talk about why Pandas has all these limitations today. And when I was coming up with this talk, I was kind of on the edge about how deep I wanted to get into the terminology. Because at the end of the day, you as an end user just want to go in and say, push it to the database or pull it back from the database. And I got by for years without worrying about what the DB API was and what SQL Alchemy actually did and all this stuff. So I don't want to go too deep into what those libraries do, but I still want to make sure that we have an understanding of like the building blocks that are in the ecosystem today and how they kind of work from the ground up. So the very first thing, everyone's used the term driver before, maybe without thinking about what it is, but a driver is simply a library for interacting with the database. You've historically heard about ODBC and JDBC. These are both their own APIs for interacting with databases, right? So they aren't exactly the same, but you know, the ODBC specification may say something like, okay, we need a function that connects to the database, and we need a function that gets rows, and a function that iterates over rows. And as you iterate over rows, here's what the results should look like, right? So they set up that API, and the driver will implement that API specific to a database. Whether it's SQL Server or Postgres or SQLite, you kind of just use that ODBC API and things work. It's worth mentioning that ODBC and JDBC came around kind of in the 90s. And if you've been following the trends in data analytics for the past 20 years, I mean, we've started to get columnar databases be more common in analytics. They weren't even around in the 90s when ODBC and JDBC was created. So JDBC works with rows, doesn't even work with columns at all. ODBC kind of does, but most drivers that you use probably today with Pandas don't support that. So there's definitely time spent, time wasted going between rows and columns between all these tools and formats and things like that. which ADBC solves. So we'll talk more about ADBC later, but that's kind of a pretext for that. In Python today, on top of these ODBC and JDBC drivers, you have the DB API 2.0. So, like I said, ODBC is an API, DB API is an API on top of an API. So it's really from the Python space saying like, hey, I need, in Python, I just want to say execute, and the driver needs to know what execute means. Or I want to work with the cursor, and the driver needs to implement like what a cursor is. That was created in 1999. Again, think about the timing. We're not thinking of columnar databases back in 1999. If you care about all the details, look up PEP 249 and have fun with that. Finally, we have SQL Alchemy that sits on top of the DB API and basically wraps it, right? So every database can have differences in terms of syntax requirements, how it handles transactions. SQL Alchemy tries to abstract this and says like, hey, if you're working with Python data structures, like a list, don't worry that like this database requires double quotes for escaping, and this one uses backticks, and this one is transactionless or whatever. SQL Alchemy will say, okay, here's a list, just take this Python list, and I'll take care of telling the driver specifically what it needs to know. And in Pandas, we use SQL Alchemy. They have a low-level API that we utilize, which I think as an end user, if you started writing direct SQL Alchemy, you wouldn't necessarily use. But it helps Pandas like not have to worry about transaction management as much. There is a higher level ORM, which if you use SQL Alchemy directly, you'd probably use that today in your own library code. But it's worth mentioning that I'm going to talk during this presentation about how we don't use SQL Alchemy for high performance. That doesn't mean SQL Alchemy is bad. Just realize that like it's a pretty generic tool, right? It's not made for high performance columnar data extracts or data movement. It's really for generic Python data structures. So it serves that purpose well, but as far as you as an analyst or data engineer, whatever your role is, as far as you may be concerned, it's pretty slow to do that. What you're used to in working with Pandas is pretty jarring how slow it is. I took this visual just to kind of reiterate what I talked about on the previous slide. This is from the ADBC introductory blog post as well, which I've shared the link there. But just to kind of drive home what we talked about visually, you see in the middle here, we have JDBC and ODBC APIs and drivers. This doesn't picture the DB API or SQL Alchemy, but they kind of happen on the left-hand side, right? So you have in that top left corner, if we were to make this specific to Python, all that interaction would happen up there. And you see in the bottom left-hand corner, we're working with rows, okay? So pandas, Arrow, a lot of the data frame libraries are not necessarily row-oriented. They think in terms of columns. You get much faster operations when you just add up a column than when you add up rows. So that, again, just visually speaks to some of the tooling and architecture mismatches we have with those drivers. If we were to make kind of a process diagram over how your data gets from a Pandas data frame into a database today, this would be a pretty high level of view, right? And I've split it into a Python layer at the top and a compiled layer down at the bottom. Now, if you've used Pandas for a few years, you may realize that Pandas is not fast because it's written in Python, right? It's fast because Python is like a wrapper on top of a lot of things, but usually your implementation of high performance algorithms is done in a compiled language. So whether it's C directly, maybe C++, we use Python to do that. All the heavy lifting is done down in compiled code, and that's what makes it really fast. You're not interacting with the Python left-hand run. So anything in this top lane is slow, anything in the bottom lane is fast, and you can see that we don't have a lot of fast stuff in this diagram. Okay, we have our data frame data underlying our Pandas data frame down in that compiled space, but we're immediately, the moment we use SQL Alchemy today, jumping up in that Python runtime at the top. we're looping over rows, creating these strings and statements, and having the driver take care of that for us. Okay? So we're going to see the comparison diagram later with ADBC. Much more of this gets in the compiled layer, and that's how we achieve a lot better performance with the new drivers. Okay. And yeah, just driving home the limitations today. I've mentioned these already, but just to explicitly list them out. Data types missing value support and performance are all limitations of the current architecture with pandas going to SQL. And I'm going to show these in more detail in the following slides. Missing values. Okay, we're going to connect to a database. I'm going to use Postgres for this presentation. It's open source, has a rich type system, inspired a lot of other databases. So this is heavily slanted towards Postgres, although what I'm going to say here in theory could apply to any database that you work with. So if we connect to Postgres, let's assume we created a table in Postgres. You see the comments, really simple table. It's an integer column, and that's it. So, okay, this is great. I'm going to read SQL and check out my data types. And you see immediately I get a 64-bit integer back. Well, what's interesting is an integer in Postgres and similar databases is not 64-bit integers. Maybe you care, maybe you don't care about this right now. But from the get-go, I don't have the same type as my database. I've created a new type on top of that. And your type mapping, which we'll see in a few slides, can be problematic from that. But even along with missing values, let's say somehow in my database a null value corrected. I didn't have a not null constraint, or my database didn't enforce not null constraints. I run that same read SQL statement, and now I'm getting float data back. Okay, so this has been a problem with pandas for as long as I've been involved with the project. It goes back quite a few years. Something we've worked on in the past few years to make our type system more reliable. But going from an integer to a float has a lot of implications in terms of like accuracy, in terms of how big of a number you can represent, right? So there's a lot of downsides to going to float that as you work with it more. I mean, maybe when you first start out, you don't care about this, but the more you work with it, if you want an integer column to stay an integer, it's really tough today with the current drivers. And what this does is it forces you to manage types from your code, right? So if I really wanted my integers to stay integers, I have all these different methods I have to go through in today's world to make that happen. The first way is to be really explicit in pandas that, hey, I want integer D types. That's going to fail, throw an error if we get null values in on the previous slide. So it could be a viable option if you want to be super strict, but I don't know if I would want my jobs to fail just because a null value came in. That's kind of heavy-handed. It's up to you. You could also just say, hey, exclude anything that's not null. Maybe this is viable with one column, but if you have a ton of columns, it's a huge pain. And maybe you do still want to know if there's null data coming in. You've changed your query by doing this to appease the type system. In really old versions of pandas, before we had nullable integers, if you wanted to get back to an integer, you had to go through this thing where you read the data, kept it as a float, then later on you'd get rid of the missing values and do an as type. Okay, so you're doing all these gymnastics to get back to like the integer data type that you wanted originally, which is also kind of a pain. Okay, so 3 options there. I can't say which one's the best. Don't worry, we have more options. In more recent versions of pandas, you could use nullable integers. So if you change your lowercase ints to capital I ints, you get a nullable integer back. So you see in this case, I actually do finally get a 32-bit integer like I had in my database to begin with. And since Pandas 2.0, we've started to add this D-type backend to some I/O methods. Right, so you could use that here to say, I'll allow nullable NumPy types or higher data types. And depending on the backend I've chosen, I'm either getting back a capital I in 64 or lowercase I in 64. Okay, so that's, I think, 6 different methods I just went through. Which one is the best? I don't know. Probably since 2.0, I'd go with one of these, but it's really dependent on your use case. And that makes things much more complicated than they need to be. Relatedly, if you wanted to read in a table and write it back to the database, kind of the way it was, it's really difficult to do that because of all the gymnastics you just saw on the previous slide. Right, so let's say I'll go back to my previous example in the preceding slides. I'm just going to read in this one column, and it's going to give me back a 64-bit integer, even though I created an integer to begin with in my database. If I write that back to a new table, you see my types aren't really matching, right? So it's really hard to get your data types correct. If you create new tables, you're kind of just, you'll probably by default get a ton of 64-bit big ints or whatever data type your database has. So yeah, that's pretty annoying. And performance, okay? This is a fun topic. Again, I'm just going to create a sample data frame here. The data is not important. I'm just taking random integers, 1,000,000 rows by 10 columns. Pretty simple. There's a million different benchmarks you can do here. But if I were to time how long this took to write to my Postgres database today, if I just use 2SQL out of the box, what that does is it creates one insert statement per row of data. So if I had a smaller data frame, 3 by 3, values 1 through 9, I'd basically be sending 3 different insert statements to the database today. And it's kind of slow, right? So it probably took me less than a second to create that data frame I just showed on the previous slide, but it takes me over 22 seconds to write it to a Postgres database. If you use other I/O methods in pandas, that's super slow. CSV is probably less than a second. Even Excel, which is a slow format, I think would run laps around this. So not a great start. But if you've read the 2SQL documentation, you see we have all these options that you can use to tweak how you want these SQL statements to go to the database and hopefully make it faster. The first one is method equals multi. Sounds great. Instead of doing one insert statement per row, I can just put everything into one big insert statement, right? So if there's any overhead to doing an insert statement in my database, in theory, I've gotten rid of this. And what's funny is, you know, I consult for a living, and I'm pretty sure I've told a lot of people that this is faster and a good thing to use instead of the standard default. Well, when I was going through this presentation, I found out that I was horribly wrong. I've probably been giving bad advice for 5 years in that front. You can see here we went from 22 seconds to 2 minutes just by changing that one keyword that we thought was going to help us with performance. And that is not good. It's super slow. But don't worry, there's still more options we can tweak. So we have method equals multi, and we can add a chunk size into that. Okay, so now I can maybe get the best of 2 different worlds and say, okay, well, an insert statement per row is probably too many inserts, but I can't do it all at once because that would be a huge statement I'm sending to the database. So why don't I chunk it up and say, okay, by some chunk size, just send that many insert statements into the database. With our simple example again, if I had values 1 through 9 in a 3 by 3 data frame and I did a chunk size of 2, I end up with 2 insert statements. The first one takes 2 rows, and the last one takes whatever's left over. So I was really hopeful that this was going to be faster than the standard 2SQL because it's documented as being such. It wasn't as bad as the previous slide, but it still took 24 seconds, where our baseline to begin with was 22 seconds. And what's interesting here, we could play the benchmark game for days. This is a very simple benchmark with just integers. I think if you had different data types, maybe strings, this probably would be faster. I honestly couldn't tell you which one to use what. So we've gone through 3 options. There's a 4th. If you've ever gone in detail into the pandas 2SQL documentation, you can write your own method for inserting things. Okay. This was faster. It got us down to 2 seconds, which isn't bad. From 22 seconds to begin with, definitely shaved a lot of time out of that. The code looks something like this. I don't want to spend a ton of time in it. You can look at it from the documentation. But basically, this user, this was, I thought, super smart. But what they're doing is creating a custom method for Postgres that says, I know the syntax that Postgres needs to create a copy statement. So I'm just going to build a huge string that says copy A, B, and C and put all my values into it. So it's kind of like if you were to do copy from directly in pSQL. I don't know anyone that's ever done this, but for a demonstration, it's kind of just pushing it all into the copy itself and letting the database take care of that. So yes, that is faster. Copy is a faster method, but it still has downsides, right? I mean, one, you as an end user need to maintain that function, have it somewhere in your code, and yeah, it basically assumes that like whatever I make as a Python string will appease the database in the format it requires, which is not always true. So knowing that we have all these like caveats with performance, there's so many ways to do it. None are really clearly better than the other. Same comment with data types. We have ADBC coming to the rescue. Okay, so ADBC stands for Arrow Database Connectivity. If you remember the ODBC and JDBC side we looked at previously, we had rows in that bottom left-hand corner. Now we're working with Arrow data. So these drivers know how to natively interact with the database, work with Apache Arrow data, which is a columnar format, and not have to take columns and transpose them into rows or vice versa. And yeah, these are just heavily optimized to work with columnar data sets. Okay? And it has its own API as well, just like ODBC and JDBC are APIs. ADBC has its own API. So worth mentioning that everything I'm going to show you is not something you can use today in Pandas. So this is out of the development labs. I put the PR that you can track this in if you're interested in seeing the development. Pandas 2.2 should be out in the next few months, I think before the end of the year. ADBC 0.8 should be out in the next few weeks. So once those two are there, you'll get all the high performance stuff I'm about to show you. In the meantime, you could still use ADBC, but it's not going to be fast like I'm showing you, right? So just make sure that if you want to get the numbers that you see here, that you have these minimum versions when you use these libraries. And this is what the process diagram looks like with ADBC. So we've taken all that work that we did earlier with ODBC and JDBC that happened during the Python runtime, and we've moved that down into compiled extensions. So by avoiding that interaction with Python, we are getting significant performance speedups. Right? There's no SQL alchemy required here. You're not using the Python DB API directly. You're really using ADBC and its drivers to do high performance transfer of Arrow tables. And just going in the same order we went through issues, let's talk about missing value handling. Okay, so this is what it looks like to use read SQL with the ADBC driver. I'm really still just calling read SQL. And in this case, I'm specifying a d-type backend equals PyArrow, which means like, just give me the PyArrow or the arrow types back. Don't do any kind of translation of the types. And in this case, I actually finally get a 32-bit integer that's nullable without having to specify anything. Okay, so this is like the only method that we've seen so far that actually can produce or reproduce whatever types are in the database in the data that you're working with locally, which is fantastic. If I insert a null value back into that sample table, nothing changes. It's still a 32-bit integer. Arrow data types are, at least the integer data types are nullable, so I'm not changing my data types because the data changed in the database. Much simpler that way. Relatedly, I can actually round trip things, right? Because these types match what I get in the database. If I read a 32-bit integer from the database and I write it back all in pandas, I get the same exact table that I started with. Okay, so previously when we wrote it back, we got a big int. Now we're working with an integer. So aside from constraints and other metadata that might be attached to the table. If you're talking about strictly the types and the data itself, you can replicate that round tripping with the ADBC drivers. And performance. This is this same code, and I'm just calling toSQL here. Now, I'm down to 658 milliseconds out of the box. I'm not changing any other settings. I'm not creating these custom copy commands. I am simply saying, use the ADBC driver, write this to SQL, and I've gotten faster performance than any of the other hoops that I had to jump through the first time around. I mean, by default, I think the default with ODBC was 22 seconds. So this is 35 times faster just by using a different driver, which is pretty nice. And just to put that visually for you, there's the default somewhere above 20 seconds. The multi-method that I've mistakenly advised people to use in the past was 120 seconds. Copy was okay if you could do that manually, but ADBC, again, no extra configuration, no extra code. You're picking the driver, you're getting better data types, and the performance throughput is just insane because we're not transposing between rows and columns. We're avoiding the Python runtime. All in all, it's just a better design start to finish, and you just see that played out in the numbers. Kind of a bonus is a better type system. So this is a not necessarily complete listing of all the different types used across different databases, open source ones, as well as, I called it NumPy/pandas, right? So pandas has used NumPy historically as a backing. So these are really NumPy types, but what you would see through pandas. And then we have Arrow, Postgres, and SQLite. And I've tried to line up where they all kind of fit and match one another. And you can see that Arrow has really nice, rich data types beyond what Pandas offers out of the box that match what a database like Postgres and any other database in theory would allow for. So kind of that first thing that doesn't have a value for Pandas is dates. I've run into this issue a lot of times, especially with people new to Pandas, that they don't realize there is no date type in Pandas. There's only a timestamp or a date time, really. So I've seen a lot of people, collect all these date time, date objects into a NumPy array, which is really a object-y type in NumPy. They run into a database. They can't understand why they're not getting the right data, why it's so slow, why the data operations don't work. Well, Arrow has an actual date data type. So if you wanted a real date in your target database, you can use the Arrow type system to accomplish that. Binary data, I'm not sure if there's that many people that would use that, but it's an opportunity there. You see even at the bottom, there's decimal arrays composite types. Now I put an asterisk next to those in Arrow because I know for a fact that they haven't been implemented in the driver yet. But there could be a future where, if you have list data or an array data that you want to keep in a column in your database, that you could write them through the ADBC driver as long as your source data has that same data type as well. I don't think that would be possible at all with ODBC, at least without some significant rewrites to the Pandas architecture. So yeah, generally you just get a much richer type system. The types match better. And it just gives it lets the driver do a lot more heavy lifting that you as a developer really don't or shouldn't care about. You have a data type here, you want a data type there, just send it and let the driver take care of all the work for you. Okay, let's talk about ADBC itself for a little bit. Again, I mentioned this is the Arrow database connectivity, replacing ODBC and JDBC. It's pretty new, so that blog post that was in one of the earlier slides, I think, was created in January of this year, right? So it hasn't been around that long. So there's still lots that can be done to make these better. Number one is more drivers can be produced. So this is development documentation as to what is available today. So we talked about in this presentation the Postgres driver a lot. SQLite is there as well. If you use Snowflake, there's a Snowflake driver. BigQuery was implemented maybe last week, so that's like brand new. And then Flight SQL, which I'll talk about that more in the next slide, is there as well. So there's still databases missing here, right? I mean, SQL Server is really popular. We don't have an ADBC for SQL Server. I think that would have to be implemented. There's a million different databases out there. So as long as that gets implemented, it would be able to leverage that. But there's still work to be done to actually create that. Is there a question in the back?
I'm just confused how you can do ADBC over JDBC.
Oh, yeah. That's a good question. I actually don't know all the details myself either. So I'd have to refer you to another developer on that. But I believe it's just they're basically taking the ADBC API and making it work on top of JDBC.
So you get the types, but it's not actually doing the columns, like it's rearranging the columns.
Yeah, I wouldn't expect this like high performance out of it or anything. I think it's just like a baseline compatibility layer. And I didn't mention them before. There's actually Turbo DBC, which is another set of drivers, and they kind of do a similar concept, sitting on top of ODBC. That's separate from ADBC, so try and keep your DBCs all different. It gets kind of confusing. But yeah, I don't think with that particular bridge on top of JDBC, it's just compatibility. It's not high level performance. Question?
So you mentioned that for like there does a BigQuery for like C#.
Yeah.
Does that mean you can work in one like that?
Not yet. Yeah.
One?
I don't know. I think the BigQuery one literally went into the development system like last week. So I don't know a lot about it. I just saw that it was there. But thanks for bringing that up. And you see the footnote down there. Anything that's listed as a support language C is really available in Go, Python, and Ruby. So this is a Python conference, right? I think we're mostly interested in Python. But you know, if you have another requirement for Go or Ruby or whatever, you could use that. I think R works as well. I could be wrong on that, but I'm pretty sure R can leverage these C-based drivers as well. So yeah, hopefully we see more over time as there's more interest and people start to see the value in it. If you would like to get involved, I mean, there's plenty of ways to get involved. And depending on like what your role is and what your interests are, I think even if you just are a consumer of these drivers, start using these when they become available. If you use Pioneer directly, you can work with ADBC a little bit more low level, but if you're a pandas user, as I mentioned with 2.2, coming out in the next few months, you can start leveraging these and not have to change anything in your code besides the driver that you picked. So make sure you use them, file bug reports, get feedback. It's all pretty new, right? So any commentary that you have is welcome, I think, on the project. Apache Arrow ADBC on GitHub. If you're a library developer and you want to work on some of those things that I mentioned, maybe like Postgres, you really want to implement the list type in the driver, or maybe you want to build the SQL Server driver as well. I think all those contributions are very welcome. And what's great is any language that Arrow supports could work here as well. So we saw the C# driver previously. Now that's limited in terms of like what other languages can build on top of that, but I think having the driver in any language of your choice to begin with is kind of the most important thing, and then the support and compatibility can always come later. Finally, if you're a database developer, you may want to implement Flight SQL. Now, I don't want to go too deep into what Flight SQL is. I honestly don't know all the details myself, but at a high level, Flight SQL and ADBC are kind of like hand in hand. Except ADBC is more about like a client interacting with the database. Flight SQL is a database, saying how clients can interact with it, essentially. So Flight SQL, if you decide to use it in your database that you may be developing, you get authentication and some connection handling out of the box, and any Flight SQL driver which we saw on the previous slide, will work with your database. So you don't need to create a separate driver on top of that, which is really nice. And a couple of databases have already done this, Dremio and InfluxDB, if you use either of them. Just because they've implemented Flight SQL, they have the driver, you can connect to them and start working with them right away. And that is it for my presentation. So I'm happy to take any questions that you may have. Listening to speakers.
So you mentioned basically columnars data.
Yeah.
Like this approach, of course, is good, but aren't we trying to use relational database for what they were not designed for? Like how this would compare to saving all your data sets in Parquet files?
Yeah.
Did you benchmark it or not?
Well, okay. So the question is kind of like how, you know, with databases historically being role-oriented, like how does this kind of compare to Parquet? Well, it kind of depends on your database, right? So I use Postgres as an example here because it's easily available, but Postgres probably still isn't even the best use case for ADBC because it is still a row-oriented database. So when I'm working with my pandas data frame and working with Arrow data, the stars columnar, I still do spend a little bit of time and effort with Postgres specifically to turn that into rows and push that to the row-oriented format that that Postgres needs. Now, if I were working with like a columnar database, what's great is I don't need to do any shifting of my data. I start with columns, I end with columns, right? There's no transposition of that in between. So with your question about Parquet, that's kind of why a lot of databases, I think historically have used Parquet as an ingestion format, especially if they're columnar, and it's faster to spit out a Parquet file and copy that Parquet file into your database, because with that, you've kind of done that work manually of saying from start to finish, here's columnar data, and that target database may know how to ingest Parquet super fast. So I haven't done any specific benchmarks around, you know, how that plays out across all these different databases, but the theory is that it should be faster than that because, or at least the same performance, and you're getting rid of that step to manually create that Parquet file and deal with that file that way.
Yeah, all the database management system, right?
Yeah. Question here?
Yeah, you mentioned the ORM API and
Yeah.
SQL. I wonder if you've got thoughts on sort of how that might apply here, or like bringing some of these.
I don't know. I don't know enough about SQL Alchemy to really answer that, I think. But I think it would be hard, right? I mean, anytime, because SQL Alchemy is really a Python library, anytime that you're taking your data into the Python runtime, you're paying there's a hit to that performance penalty, right? So unless they really change their architecture and decided that they wanted to work with objects lower than the Python level, it's never really like going to compete with the performance here, at least I think. Yeah.
So how do you actually use ADBC with a data frame? Like with the latest pandas, just if they do it to SQL, would I have to specify that?
Let me come back to well, here. Let's do this, right? So assume you have Pandas 2.2 when it releases. The ADBC drivers are distributed as their own Python packages. So you can see in this code, I'm doing from ADBC driver PostgreSQL import DB API. And then all I'm doing in that bottom section is saying, okay, with that DB API, connect to my database. There's my connection information with Postgres. Use that as my connection. That's it, right? So it fits pretty well into what you've always done in Pandas, really. Like you just use that driver specifically to connect, and okay, that may be a little different historically. Like you probably use SQL Alchemy and you can use SQL Alchemy Connect or Engine Connect, whatever it is. But otherwise, it's pretty minimal change to have to do. So you'll see those ADBC drivers now on PyPy, version 0.7. Like I mentioned, at least Postgres and SQLite, I know, and Flight SQL are there on PyPy. I'm not sure about the other ones that they've been packaged and put out there, but you can use them today.
Is there a reason that's not in the connect URL?
Is there a reason what's not in that?
The ADBC, like, will pandas not recognize that, or?
Oh, like if I
Or like
said like
it's not
PostgreSQL ADBC.
Yeah,
is
yeah.
that? Yeah, maybe it would. I don't know enough about the details of that.
Yeah.
Is that a SQL alchemy dialect thing? Okay, so there could be a future. I've just used the ADBC drivers directly here, but there might be a future where SQL alchemy can help you more easily connect to a driver like that. Because don't quote me, but I think that is a SQL alchemy thing where you say like, here's my database : here's the driver dialect I want to use.
Yeah.
So I think it could help there in the future, but for like a really simplistic like, hey, we just released the ADBC, I just started with using it.
Yeah. The point is it works. I was just curious.
No, it's a good question though. Thanks for bringing that up. Thank you.